Hello everyone. Incandescent lamps are gradually becoming a thing of the past, but despite this, they still continue to be actively used. One of the disadvantages of incandescent lamps is that they often burn out, especially at the time of switching on. This happens because when the incandescent lamp is cold, its spiral has a very low resistance. According to Ohm's law, at the time of switching on the lamp in the network, a current passes through its spiral, which is several times higher than its nominal, that is, the operating current. That's why the lamps often burn out. To prevent this, at the time of switching on the lamp in the network, you need to limit the current that passes through it. Today I want to collect two schemes that allow you to do this. The first circuit will be based on a thyristor, and the second on a field effect transistor. In the circuit that I want to assemble, a thyristor acts as a control element. This device first supplies half of the supply voltage to the lamp. The spiral of the lamp first warms up, and only then a voltage of 220 volts enters it. When connected to the network, the lamp glows at half the glow, since the current flows through it only during the positive half cycles of the mains voltage, and during the negative half periods the capacitor C1 is charged. As soon as the voltage on the capacitor reaches the stabilization voltage of the Zener diode VD2, the thyristor VS1 opens and the lamp lights up almost to full glow. The details shown in the diagram are designed for the operation of the device with a lamp with a power of up to 150 watts. By changing the capacitance of the capacitor C1, the heating time of the lamp spiral can be adjusted. I will use a 220 microfarad capacitor. Everything is ready. It remains to solder the lamp and the mains wire. Let's see how this scheme works. In the second circuit, which I will now assemble, a powerful field effect transistor acts as a control element, which smoothly supplies voltage to the lamp. At the initial moment, the transistor is closed and all the voltage drops on it, so the lamp does not light. Then the charging of the capacitor C1 begins through the diode VD1 in the resistor R1. The voltage on the capacitor will not exceed 9.1 volts, since it is limited by the Zener diode VD2. Due to this, the voltage at the drain of the transistor will be low. At a current of 1 ampere, it will be approximately 0.85–0.9 volts. This allows you to use lamps with a power of up to 250 watts. When the voltage on the capacitor reaches a certain level, the transistor will begin to open smoothly, the current will increase, and the drain voltage will decrease. This will cause the lamp to light up smoothly. The resistor R2 is needed to discharge the capacitor after the lamp is turned off. In this device, I used the KC405 diode bridge. All the details are in place, and it remains only to solder a few jumpers. Now I will solder the lamp, as well as the power cord, and let's see how this device works. The lamp turn-on time can be adjusted. To do this, you need to change the capacitance of the capacitor C1. Now I will solder a 330 microfarad capacitor and see what happens. As you can see, the lamp's turn-on time has almost doubled. This concludes this video. If you liked the devices that I collected today, then do not forget to subscribe to the InvexLab channel so as not to miss new videos and new homemade crafts. I thank you for watching and see you soon.